Hi, my name is OG. Welcome to our show, Probotix. In this show, we're building all kinds of robots, and we're practically looking for every excuse to build one. In this episode, we were looking at autonomous robots. Autonomy, autonomy, autonomous. Autonomy, autonomous. The word nomos is the Greek word for law, which means that something autonomous will make its own law. That's what it means. When something is autonomous, that means that it has the right to govern itself or control its affairs. Another word for autonomous could be self-government. Next, there are three crucial components of an autonomous robot. One is perception. Just as humans have ears, eyes, nose, mouth, and skin, which are used to perceive their world, robots have cameras, laser scanners, bump sensors, which they use to be able to perceive their environment. Next component is decision. Also, just as humans have the brain to be able to make decisions and process data that has been gathered from their senses, robots have computers like the Arduino microcontroller or a single board computers like the Raspberry Pi, which is used to process data that is gotten from the sensors. The final component is actuation. Humans have muscles, which is on their hands, on their legs, which they use to grab a cup, for example, or to walk or to run. In the same way, robots have motors, which are attached to wheels that allow them to move from one place to the other, or they have hydraulic arms that allow them to pick very heavy stuff based on the decisions previously made. Now, let's look at examples of autonomous robots. We have pilotless drone crafts, cruise missiles, and unmanned aerial vehicles, UAVs. In some cases, we have UAVs that can actually fly their whole entire mission without any human intervention. And if any intervention at all, maybe to just assist in their landing. Come to think of it, almost all car manufacturers around the world have a self-driving car. From Tesla to Mercedes to Nissan to Toyota, all these car manufacturers have self-driving cars. Think about it. Cool, right? So let me ask you, have you seen an autonomous vehicle around you yet? In some situations when you have to guide a robot, sometimes guiding a robot may be from simple to really very complex. In the case of cruise missiles, it's usually guided with a system called Global Positioning System, GPS. And those robot cruise missiles are actually guided to where they are going to. Now let's talk about something that is also very important about autonomous robots. One of the greatest fears that people have about autonomous robots is the fear of those robots becoming rogue. As in,
Talon 3, state your intentions.
My intentions are to reason with you, Eddie. All right, you messing up. You are the future, and the future's not allowed to act this way.
I am designed to destroy the enemy, just like you.
And just like me, you got orders, and right now your orders are to return to base. Good pilots follow orders.
Negative.
people have a mindset about robots that one day robots may turn on humans. We see this a lot in the movies. We see robots becoming rogue. We see situations where robots that were trained or programmed to do certain things now leaving those programs and having what we call self-awareness. That's usually one of the greatest fears that people have about robots. Yeah, that's something we should be concerned about, in my candid opinion. But really, I know people are afraid, but really, I can tell you that that time is really far away. I have an idea of how we can solve it. Pull the plug! Pull the plug! I know it's a possibility, but I think that we're still really far away from when something like that can really happen. I think. Let's look at the three components which I mentioned earlier about the autonomous bot, which includes perception, decision, and actuation. For perception for our robot, I'll be using two infrared reflective sensors, one for the right and one for the left for detecting obstacles in its path. And for decision making, I'll be using the Arduino Nano, which is going to be used for computation and processing of the data that has been gathered from the infrared reflective sensors. And for actuation, I'm using two FSR continuous micro servos, and based on what the Arduino Nano is getting from the infrared reflective sensors, it's going to determine the movement of the T-Bro using the FSR 90 continuous micro servos. The list of our bill of material includes an Arduino Nano, two continuous servo models, two infrared sensors, a breadboard, jumper cables, two 3.7 volt lithium ion batteries. We need a chassis for the robot, and we need two rubber tires, and we're also using a castor wheel. Also, we also need a battery holder. So this is the list that is included for our project for the T-Bro bot. The servo motor has a control circuit within it that allows for accurate or precise movements. So if you're looking for a motor with high torque, your best bet is a DC gearhead motor. And if you're looking for a motor with precise control and movement, a servo motor will work perfectly for you. For our servo motor, it's a continuous servo motor, and this servo motor requires specific signals to move. It's called continuous because not all servo motors can continuously rotate, as some have a mechanism in them that halts the servo rotor. To control our continuous servo, we're going to be using specific signals. To stop or break the servo motor, we need to send a signal of 90 to the servo motor. To allow for continuous clockwise movement at full speed, we send 0. To allow for continuous counterclockwise movement at full speed, we send a 180 PWM signal. To get the servo motors to rotate slowly, we send a specific signal of 99. So we have a start, and we're going to begin by reading sensors. So we're going to start by checking the left sensor. If the left sensor has detected an obstacle, and if it's a yes, then it's going to make the robot turn left. And if it's a no, it's going to go ahead and read the right sensor if there's an obstacle in front of it. If there is an obstacle, it's going to make the robot turn right. And if it's a no, and if both sensors detect an obstacle in front of it, then it's going to make the robot move forward. It's just a very simple program, and we'll have our flow going back to read the sensors all over again, and it's going to go in that loop fashion. So finally, I've just implemented my T-Bro autonomous robot, and in the next episode, I'll be taking it a little further as I'll be adding some more sensors and making the robot fully autonomous. You don't want to miss that. And remember, we have a thief to catch. Don't forget. I hope you enjoyed the show, and I'll see you in the next episode. Bye.